Today panel, my name is Boon. Today, I'm going to present my final year project, which supervised by Dr. Hasnida, with the topic Waste Epoxy Molding Compound as a Composite Gypsum Ceiling Boards for a Sustainable Potential. For introductions, the electronic components such as integrated circuits and microelectronic devices are the basic building blocks of almost all the electronic goods, and they are generally packed using epoxy molding compound, which we call it as EMC. Increased electronic components output in recent years has resulted in a significant rise in the amount of EMC which is produced as industrial waste in the molding process of electronic components package. Traditionally, the majority of the waste is disposed of in landfill or incinerated without being reused. Thereby, it might pollute the environment and wasting the resources. Gypsum is a substance that is commonly used in civil engineering due to its lightweight, flexible, fireproof, and moisture resistance. But it is also the most common solid waste in the world. In gypsum area, there is always a chance of soil and surface water might be contaminated. Therefore, in this project, we are going to apply the circular economy concept by mixing the gypsum and EMC to produce a composite gypsum ceiling board. For objective, it is to investigate the potential of waste epoxy molding compound as a composite gypsum ceiling board in order to reduce the use of gypsums, and also evaluate the properties such as thermal, conductivity, sound absorptions, and water absorptions of the gypsum composite ceiling board. This is the literature review for gypsum boards. According to ASTM test 1396, the actual testing has shown that the water absorption rate of about 40% are typical when gypsum board core materials is submerged in water for 2 hours. And this table shows the thermal conductivity of gypsum boards at room temperatures from different countries with different types of gypsums. This is the literature review for composite ceiling boards. The table here shows the physical properties of other types of ceiling board materials, and the figure shows the comparisons of sound absorption coefficients between the Acoustic Society of America. Next is the methodology. The first step is waste sample collections. The waste EMC is collected from the ST microelectronic 9 parts. The second step is preliminary experiments. In this step, we prove that the EMC cannot be melted either in oven or furnace. And the ratio for gypsum that decided to use is 2 parts of gypsum powder and 1 part of water. The third step is the ceiling board mold fabrications. The ceiling board mold is designed by using the material aluminium, and the size depends on the standard of testing that we are going to carry out later. The fourth step is the optimizations of composite gypsum ceiling boards. The gypsum water and EMC will be mixed according to 5 different percentages, which are gypsum 100% and partially concentrations of 95%, 90%, 85%, 80% of gypsum water, with replacement added 5%, 10%, 50%, 20% of EMC. The next step is development of samples. This figure shows the procedure of the mixing process. The first step is preparations of material. Sprinkle the gypsum into the water. Soak the gypsum water for 1 minute. Sprinkle EMC into the gypsum water. Mix the mixture. Pour the mixture into the mold. And lastly, shake the mixture until flat. The next step is sample analysis. In this project, the FPR, SEM, EDS, water absorption, sound absorptions, and thermal conductivity are being tested. The decreasing of the percentage of water absorptions when EMC is mixed might due to the quantity of void decrease. As a result, when the sample are submerged into the water will seep into the pores and result in higher percentage of water absorptions. For example, from the sample with 100% gypsum water, it can be observed that there is a lot of air bubbles pop out, as shown in figure A. When EMC was added into the gypsum water, it will actually decrease the quantity of the pores because EMC can occupy space. It can be seen by less bubble pop out from the surrounding of the sample, as shown in figure B. Based on the figure, the sample with 100% gypsum water had the lowest sound absorption coefficient at the frequency 125 Hz and 2000 Hz, while the sample with 80% of gypsum-water and 20% ESC had the highest sound absorptions at the frequencies 125 Hz and 2000 Hz. The increase of the sound absorption coefficients when EMC is mixed was due to the size and quantity of pores in the samples. That is because more holes in smaller size can improve the sound absorptions. Based on the result for thermal conductivity, the decrease of thermal conductivity when EMC is added is due to the porosity of samples. The quantity of void and pores, which is more closely related to the density, and the void assistance in transporting heat to the others are the main factor that affect the thermal conductivity of the materials. Conversely, if the number of void or pores in the finished board was reduced, the thermal conductivity values of the material will also be decreased. In conclusions, based on the result and discussions, we can notice that the quantity of size of the void or pores are closely related to the thermal conductivity, sound absorptions, and water absorptions. It is recommended to choose sealing board with lower heat conductivity, lower water absorptions, and higher sound absorptions. Therefore, the sample with 20% EMC added to the gypsum-water show the best properties for sealing board. Therefore, I can conclude that the objective of this project is achieved. Thank you.